Welcome back to part 2 of chapter 4, lesson 2, adding rational numbers. We're picking up off of the resource that says example 4, add rational numbers, where they've given us a mixed number, 1 3/4, plus a negative fraction, 1/6. And we're going to move through the steps of this instruction, and you're going to find they're very similar to what we've done before. First thing they're going to want you to do is change that 1 3/4 into an improper fraction, which is going to give you 7/4. Now the next question I have is, are they going to make their ugly problem pretty like I say to do? And, well, we've got to wait to find the least common denominator first. The least common denominator was the least common multiple of the denominators. So the least common multiple of 4 and 6 was going to be 12. 4 went into 12 3 times. 3 times 7 is 21. 6 went into 12 2 times, and 2 times 1 was 2. And now when we take that next step, oh, they haven't made it ugly, pretty yet. They took 21 plus a negative 2 over that common denominator of 12. And now what are they going to do? Well, they never did make it pretty like I would, but I'll show you one like that, I'm sure, where they said 21 plus a negative 2, that's the same thing as 21 minus 2, because a positive times a negative is a negative, and 21 minus 2 was going to be 19 over 12. Changed that back into a mixed number to give them 1 7/12 as an answer. And I'm not going to type that in there, but you should for your notes, because the answer is right there given to you, 1 7/12. Now we have a new problem that the textbook wants you to work on your own, but I'm not going to have you do that yet. I want to work through one slowly with you, showing you the work the way I would show it. The problem is negative 2/3 plus 3 1/9. So I'm going to come over to my scratch page here, and I'm going to change it to my pen tool. And now first thing I'm going to do is change my mixed number to improper fraction. So I'm going to have a negative 2/3 plus, do the Texas thing there, 9 times 3 is 27, plus 1 is 28 over 3. Excuse me, that's not over 3, that's 28 over the 9 that you see right there. Now I've got to find the least common denominator. The least common denominator is the least common multiple of the denominators, 3 and 9. So that is going to end up being 9. So I'm going to end up with a negative something over 9 plus something over 9. Right here, 3 went into 9 3 times. So I'm going to do 2 times 3. And that's going to end up giving me a 6. Now don't put all these squirrelies here. I'm going to take them back off. I just wanted you to see where things came from. So I'm going to end up having a 6 right there. And of course that one's already over 9, so we don't have to do anything with that. And now we're at the point of saying signs are different. You notice I'm not taking and putting all that over the 9. I'm just going to go ahead and work it. Signs are different. Find the difference. The difference between 28 and 6 is 22. With the sign in front of the larger number, that's going to be 28. It's positive going in front of your answer. So we have a positive 22 over 9, which you can just leave as 22 over 9. Come off to the side to do your round robin. 9 goes into 22 2 times, which is 18. With 4 left over, 2 4/9 is equal to 2 4 over 9 for my final answer. Come back to my page and let's type that in and check it, see how we did. 2 4 over 9, accept, and we're good. Now it's time to really step up our game. We have negative 2/5 plus 2.3, or 2 3/10. So we're adding a fraction and a decimal. And the question for the think about is, how would you begin evaluating the expression? Well, the way I would do that is I would ask myself, can I change 2/5 into a terminating decimal? The denominator is 5, and as we've already talked about, if the denominator is only multiples of 2 and or 5, it can be rewritten as a terminating decimal. Because of that, you can solve this as a decimal problem or as a mixed number problem. But if 2/5 was only able to be written as a repeating or a non-terminating decimal, then you would have to work it as a fraction. You would not be allowed to work it as a decimal problem because your answer would not be precise. So let's get started. They decided that since 2/5 does work as a terminating decimal, they're going to write both of them as decimals because they don't believe that fractions are your friends like I do. So they took that -2/5 right here and they changed it to -4/10. Now let me show you real quickly why that is. So I'm going to come off to the side. I'm going to take where I have a -2/5. I'm going to multiply that times 2/2, and that's going to give me a -4/10, and we would read that as -4/10, also known as -0 and 4/10, written as a decimal. That's how they got that decimal there. So they have -0.4 plus 2.3. At this point, you have signs are different. Find the difference. The difference between that is going to be a 1.9. Is it positive or negative? The sign in front of your larger number goes in front of your answer, so it's going to be a positive 1.9. We're going to check that, and then you can say that therefore -2/5 plus 2.3, that's also going to be 1.9. Now method 2 says to write both add-ins as a fraction, and they've got a video here to teach us how to do that.
To add rational numbers in different forms, begin by writing the numbers in the same form. One way to add a fraction and a decimal is to write the decimal as a fraction. When writing a decimal as a fraction, use the place value of the final digit as the denominator of the fraction. If the fractions have different denominators, rewrite one or both fractions using a common denominator. To rewrite a fraction, multiply its numerator and denominator by the same number. Next, add the fractions. Move any negative signs to the numerators of the fractions. Then, add the numerators and write the result over the common denominator. Finally, simplify the sum and rewrite as a mixed number.
Well, that was an awful lot of information thrown at you very quickly, so let's see if we can slow it down a little bit and look at how to work that problem. The problem they gave us was -2/5. That's already a fraction. We're going to leave it alone, -2/5. Plus, and we would read this number as 2 3/10. 2 3/10. Write it just like it says. Next, we're going to take and change a mixed number to an improper fraction, -2/5, plus, use your Texas approach, 10 times 2 is 20, plus 3 is your 23/10. Then we're going to find our least common denominators. The least common denominator is going to be a 5. I'm sorry, it's not going to be a 5. I totally lied to you there. Least common denominator is going to be a 10. So from there, 5 goes into 10 2 times. 2 times 2 is 4. The 23/10 stays just like it was. Now we're going to take and look at our problem. Signs are different. Find the difference. So that's going to end up giving me 19/10. Sign in front of the larger number went in front of my answer, and of course 19/10 is the 1 9/10 that they came up with that other way that they worked the problem. Now it's going to be your turn to work one. On this problem, first thing you need to ask yourself is, can 1/7 be written as a terminating decimal? If it can't, you have to work it as a fraction. Go. The answer to that question was no, because the only way it can be a terminating decimal is if the denominators are only divisible by 2 and or 5. So we have to work this as a fraction. So the first thing I'm going to do, I'm going to rewrite the 1/7 and the 8 3/10. I'm going to write exactly what I'm hearing, 8 3/10. From there, I'm going to change this into a mixed number using my Texas approach. That means I'm going to have 1/7 plus 10 times 8 is 80 plus 3 is 83/10. From here, we're going to find our least common denominator. The least common denominator is going to be 70 for this one. 7 goes into 70 10 times. 1 times 10 is 10. 10 goes into 70 7 times, and 7 times 83, that's going to be 560 plus 21, 581. Next thing we're going to do is we're going to add our numerators. See if I can get my mouse to work here. I'm going to add my numerators and leave my denominators alone. So 10 plus 581, that's going to be 591 over 70. Now comes the part that's going to be a little bit of a challenge, changing that back into a mixed number. So I'm going to come off to the side, 591 divided by 70. And if you remember when I've talked to you before about dividing fractions, dividing big numbers, what I suggested you do is in your head, scratch out the last digit and say how many times does 7 go into 5? That'll be 0. How many times does 7 go into 59? That's going to end up being 8, which is 56. So the 8 is going to be my starting number right here. I have a 0 there. 8 times 0 is going to end up being, I'm sorry, I screwed that one up just a little bit. I got to put that one more space over. So 70 is going to go into 50, 70 is going to 59, 0, and 7. So 70 will go into 591, probably 8 times. 8 times 0, 0. 8 times 7, that's going to end up being 56. You subtract that, you're going to have 31 left over. And that's all as hard as a division gets on this one, because from here, we're going to do our round robin, 8 and 31 over 70. That sounds like a really off-ball answer, but I think it's going to be right. Let's find out. 8 and 31 over 70. Accept and check. Our answer check. Good supporting work. That's what it's supposed to look like, guys. Now the next thing the textbook wants us to think about is using the commutative property. The commutative property of addition says that order does not matter when adding. So we can rearrange the different parts of this problem any way our wee little hearts desire in order to make the math easier. And that is exactly what we're going to end up doing here. So for this example problem they give us, we're going to take, you've got a fraction, a decimal, a fraction, and a decimal. And we're going to rewrite them so that the orange fractions are going to be together and that the green decimals are going to be together. And that's going to make our math a little bit easier, less things we have to convert later on. From there, you would rewrite it so now you can see your orange fractions are together and your green decimals are together. Now they're not going to solve this problem, but when we come back for part 3 of adding rational numbers, we're going to work together and we're going to solve a problem using the commutative property of addition.